Hello, my name is Rodrigo and welcome to this video on the solar PV power modeling behind the PECD 4.2. Throughout a few slides, we will discuss the following topics: the modeling workflow which is set in place, the PV typologies which are now provided in PECD 4.2, some practical considerations, and wrap up with conclusions and future expectations. In PECD, we calculate historical and prospective PV capacity factors. To do this, we collect gridded weather data, which are processed by a PV conversion model and then aggregated at different spatial levels. We have in place a physics-based PV modeling chain, which considers solar irradiance and air temperature to estimate the PV capacity factor. In it, we consider optical, thermal, and electric losses. However, we do not yet account for snow, soiling, module degradation, curtailment, shading, nor storage. The PV model takes several contextual factors into consideration, such as the weather, the apparent position of the sun, the tilt and orientation of PV modules, and land use. These impact not only the magnitude, but also the seasonality of the PV capacity factor data. In PECD 4.2, we address the fact that this technology can be implemented in very different contexts by building four distinct PV datasets: rooftop residential, rooftop industrial, utility scale fixed, and utility scale tracking, in this case horizontal single axis. Typically, these vary in characteristics such as module tilt and orientation, ventilation conditions, and system size, which in turn influences overplanting. To make the video short, we included more details about this in Annex. These variations across typologies lead to different overall capacity factors, but also its intraday and intra-annual seasonality. In the plots below, we see an example for Spain 2023, with the tracking surpassing fixed setups mainly between April and September. But in the end, the goal is to obtain a total PV time series. To fully exploit PECD 4.2, TSOs will need to estimate how much each typology contributes to their PV portfolio, so that these are all integrated for the region of interest. We are well aware that this is no easy task, and we are here to support you. However, we also believe that this much is needed to go beyond the generic modeling. Finally, no need to find the perfect data. A plausible estimate is often better than none. Looking back at the modeling, the fact that it is physically driven means that the reference data is key for setting up assumptions and validation. Nonetheless, we aim to make our assumptions as adaptable as possible, so that the model becomes more resilient to situations of data scarcity. Also, while dismissing PV downtime, curtailment, or storage is not ideal for validating the model with historical data, it also means that the variability found in the PECD is essentially driven by weather and climate. Also, a topic that has come up several times when talking with TSOs concerns the type of PV capacity used when handling these capacity factors. All PECD4 versions consider DC capacity in watt peak, which relates to the PV modules. It is very important that TSOs to be aware of what type of PV capacity they have at hand. For PECD4, TSOs with AC capacity data will need to account for a certain level of overplanting, otherwise you will obtain excessively low values. Just like before, more details on these are provided in Annex. We are confident of the added value of the C3S energy contract, providing reliable PV data, now available at the typology level. This unlocks not only a more accurate, but also more flexible modeling, with TSOs now being capable of assessing different PV technology roadmaps. So, for the remainder of this contract, we expect to support TSOs in ingesting the new data and workflow, as well as proceed with an analysis on climate change impacts. Additionally, we will seek to continue clarifying the AC-DC capacity topic and overplanting altogether. In terms of longer-term planning, we believe that the evolution of this service would focus on continuing to improve the modeling, for example by integrating snow impacts, expand the data collection, and explore the possibility of integrating more typologies such as floating PV. Lastly but not least, we would like to stress how important your feedback, requests, data and insights are to us. Over the past 2 years, many rich interactions took place, and would like to invite those who have yet to do so to reach out to us. Your support is valuable to the continuous improvement of the PECD. Thank you for your attention.